ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರ. ನಾನು ಮಣಿಭೂಷಣ್ ಡಿಸೂಸ. ನಾವು ಲೈನಕ್ಸ್ ಎನ್ವೈರ್ಮೆಂಟ್ನ ಬಗ್ಗೆ ಕಲಿತಿದ್ದೇವೆ. ಇಂದಿನ ಸೆಷನ್ ನಂಬರ್ 20 ಆಗಿರುತ್ತೆ. In today's session, we are going to look at disk drivers. In particular, what are the functionalities of a disk driver? The learning objective is to configure the disk drivers in order to appreciate the content which are presented over here. You must have the basic knowledge of drivers. Now, what is the purpose of having a disk driver? We are looking at the files in the Unix environment as a data block. So we assume that the file consists of blocks of data. So this is what is our analogy. However, when we look at the real disk, a disk consists of tracks and sectors. So we are all familiar with that. So there will be many tracks and sector. Now we need to identify the blocks within these tracks and sectors. So in other words, when we say that I have a file here, we look at the file as a block of data. Now when we really want to save this particular file, we have to identify the sector in which these blocks need to be saved. And who is going to do that particular work? That work is carried out by the disk driver. Okay, so disk driver translate our block addresses. So we know that we have inode and we have the table which shows the maybe direct, first indirect, double indirect, and maybe a triple indirect way of accessing the data block. That is how we look at the files, but all of them have to be somehow need to be written to the disk. Okay, and this translation from the flat file to the three-dimensional world of the disk. So you know very well, if you look at the hard disk contains of many disks. So we have many disks inside the hard disk, and we are all familiar with that. Okay, so when we look at the hard disk, it's not just one disk, many disks are placed, and so it becomes which is the platter, which is the sector, which is the track, and which is the sector. So it is a three-dimensional representation within the hard disk. But when we look at a file, in generally when I look at a file, I say that file is opened here. This is my current offset, and the file is going to end here. So I look at the file in terms of it has a flat representation, but this flat representation has to be converted into a three-dimensional or a 3D address, and then need to be stored onto the disk, and this is performed by the disk driver. So the disk driver translates the file system address, which consists of the logical number and the block number, into a particular sector on the disk. Now the next question is, how does the particular device driver get the address? There are two ways in which it can get it. One is from the buffer pool. So we know that whenever we read or write from the disk, we have the buffer pool. This buffer pool contains the buffer header, which contains the device number as well as the block number. Or we can also pass the logical, that is the minor device number, and the parameter that are associated with them. Okay, so based on the device number, now again let me tell you, when we look at the Unix system, a physical hard disk may be divided into logical partitions, and a physical hard disk is given a major number, and every partition is given a minor number. So if I know the major number, I know the device. If I know the minor number, I know the partition. So if I'm able to supply the minor device number, then I know from where the partition is beginning. For that, I can add the offset and get the appropriate sector number. So if I know that, just to give you, just to confuse you, let me say, suppose if I know where is my partition beginning, let's assume that my partition is beginning somewhere here. So I have a partition that is beginning somewhere here. Now from there I need to search for the offset. So how many sectors I need to move in order to achieve that, or in order to reach to that particular block of data. Okay. Disk driver uses the disk number to identify the physical drive. I've already told you every disk has the major number that identifies the disk and the minor number that identifies a particular partition within the disk. It adds the block number of the file system to go to the particular sector and then starts reading it. Okay. Now there is a minor problem with this knowledge, this analogy, and the analogy is if I buy a hard disk, I can partition it. Let's say if my first partition is say 100 GB, second partition is 100 GB, and third partition is 100 GB. If you buy your hard disk, you may get your first partition 200 GB, and you may have your second partition 100 GB. Somebody else buys it, so they may start with the first partition 150, next partition is 100, and the last partition is 50. So these partitions that we are talking about, it varies. Okay. As an administrator can configure the file system section to appropriate size. Okay. So now the question is, how do I know that from where I have to start reading this section? So which is the particular section? So you have a disk here. If all the disk on earth, let me take that. If all the disks are on earth are all partitioned equally, then there is no problem. But now Unix is flexible, and it gives you a choice of partitioning your disk into your requirement. Then the next question comes, how do I know that this is the starting location and this is the starting location, or this is the starting location? Because administrator can configure the file system according to their requirement as the appropriate size. So you cannot get a generic position on the disk. It's going to be a difficult challenge. For that, what every manufacturer has done is, whenever you buy a disk, whenever you format a disk, or whenever you make the disk ready for the first time, the disk itself is partitioned. There will be some blocks which are reserved, which you cannot use it, which the system will use it, or maybe the driver or the controller will use it. One such block is the boot block. So boot block is the first sector on the disk, which will not be used. Generally first four sectors are reserved, which cannot be used by anybody to store their data. So a boot sector, we call it as a boot sector. Okay. Boot sector is always fixed. Whether you like it or not, you just lose that much of size from your disk for the boot block. It is not very large, it is not 1 GB of data, it may be in bytes, kilobytes, maybe you may lose like 2 MB maximum, I am saying. Okay. That's not a very big thing, because you have 1 tera hard disk and you just lose 2 MB. It doesn't make much of a difference, but that is permanently etched onto the system, so you cannot use it. Your files, your data, everything you can use it. However, this particular place within the disk are reserved. So it's kind of a, there is a kind of a reservation for some sectors. Okay, so when you create a boot sector, you cannot use it. Now, I don't know whether when you use the Windows actually in when if you have installed the Windows on your own and if you have created the partition, Windows actually says I'm going to use some disk space for my purpose. Okay, if you have used Windows 10 or any other newer version, Windows 10 itself is the newer version. There is no newer version than that, but we installed Windows 10. During the installation, Windows 10 says that I'm going to use some system, some partition for my purpose. That in that partition you can't store anything. User information is not stored, but Windows will store its information. Okay, so that's kind of result. It's not a very huge so don't think that okay, if I install Windows I'm going to lose a huge lot of disk space. No, it's not that kind of thing, but some disk space, some penalty has to be played, so you can't avoid it. So when in the same way, when you buy a disk, a new hard disk from the market, and when you format it and when you create it for the first time, some part of it will be used for the reservation area. Some part is definitely used by the file system. You know very well, you need a super block for storing the inode information. So that in the, you cannot say that okay, my disk is full, so okay, go and write in the super block area, because that super block area is free. Go and write in there. It's not possible. If you write into the super block area, then you won't get the node informations, inode information, then you will not be able to read anything. Okay, so what I mean to say is when you buy a disk, some areas are reserved. Okay, in particular, boot block is reserved. Boot block contains bootloader. Okay, bootstrap we call it as, which contains the information to load the OS into the memory when the system boots up. Okay, there are other sectors. Sometimes you have the partition table information that is also stored in the disk. Okay, these informations are hard coded information, okay, onto the disk. Like partition tables are stored into the disk. Partition tables can be used for manipulating the partition. The disk driver can read that information and use them to appropriately get the place. So when you have the disk has every disk has a boot block, remember that, and there will be a partition table that says from where the partitions are beginning. So which is this partition, what is the size of the partition, and where the other partition, from which sector to which sector the partitions are there. That information will be stored within the disk. So it is easy for anybody to access the content from the disk. Now we know that disk is very slow, and as compared to the speed of the CPU, the disk is very slow, and we cannot simply read the content of the disk at leisure. So you must have optimized the reading or writing operation so that it is much faster. Okay, you have studied about the operating system, wherein you have studied about disk scheduling. Okay, now this disk scheduling is done either by the device driver, or in most of the modern disk, if you buy it, there is something called as a disk controller, which is a physical chip, that is your electronic chip, which is there on the with the information. Actually disk itself contains a small microprocessor which knows how to handle the disk. It will not using that microprocessor you may not be able to play games, PUBG or other thing, but that microprocessor, usually called as a controller, we say, that controller knows how to control the disk arm, the movement, the how to regulate the speed of the splinter, and so on and so forth. So this particular disk controller takes care of scheduling the disk and maybe positioning the arm and translating the data between the CPU and the appropriate sector. Everything is handled by the disk controller. In olden days, this is very, very, very old. Maybe even I was not born during that time. If you had brought the disk very old, during that time, it may not have those disk might not had the disk controller. In that case, the entire thing has to be taken care by the disk driver. Now today, if you buy a disk, the disk will come with its own controller. There is some electronic chip or electronic circuit board which is part of that particular device, hard disk or anything for that matter, which will take care of translating the data and writing it at an appropriate location. However, you must understand that there are some programs which directly read and write to the disk. So usually we say that it is a raw read and raw write. So why we say a raw read and raw write is it bypasses the general regular way of accessing the file. So regular way, we go to the inode, we go to the block size, we then search for the block size and then read or write. So that's generally it's a good way of accessing. But there are some utility programs, so they do it in bad way. Now they are not bad programs, by the way. They are used for maintenance purpose. Like I have already talked about a utility program called as AFS check. So file system check. So the file system may be corrupt because of the power losses or maybe system failure, maybe system abruptly hanged or shut down. Anything can happen. So during that time the file system may be corrupted. In that case, when the file system is corrupted, you can't read the content in a regular way. So these particular utilities, they go and read the content sector by sector. So they simply start reading the content sector by sector, then try to map them to the file name. So they will override the general idea, and there is this MKFS. MKFS is used to make the file system. Okay, so oops. So this system will override it. So in the Windows, you have heard about formatting the disk. In Linux system, the MKFS is used to create the file system. When you create the file system, it is going to create a super block, inode list, and a link list of free disk blocks, root directory, everything. It's going to create the new file system for you. Okay, so it's like creating a fresh file system. You can use MKFS. Don't try that thing on your Unix system if at all you have one, because it's going to wipe out all the content. So be careful with these utilities. Because they don't care about the blocks and sectors. I have already told you. See, they are going to do it in a raw way. They just go and write it. So if you have your movies, songs stored on your disk and you use MKFS successfully, it's not easy, but let me say you do it successfully, then you will end up in wiping out all the contents which are there in your disk. So don't try them. You can use man to see more about it, what it does, and how to use it, but unless and otherwise you are very sure, don't try to format the disk, because it's going to wipe out the content. However, you can try this FSCHK, that is a file system test, that is FSCK, to check the consistency of the file system, and if there is an error, it's going to report that. Thank you for your interest. We will meet again in the next class. Thank you.